So here are your notes 5.4 for the Honors Algebra 2 course. In these notes, I'm going to show you guys how to use the sum and difference of two cubes to factor. Sum and difference of two cubes is basically a method of factoring when you have two perfect cubes being added or subtracted. And then also you're going to learn how to factor by grouping. That's another method of factoring. And keep in mind, the reason why we're factoring is to help us eventually start to solve these equations. When you solve equations, you're basically finding the x-intercepts of a graph. So this is kind of steps to get us towards solving. All right, so first off, factoring, since both of these include factoring, you got to know where it comes from. Factoring is basically the opposite of when you multiply two polynomials. So here's one polynomial times another polynomial. When you multiply these, you're going to end up with a single polynomial. So go ahead and try multiplying these out on your own. If you want, go ahead and pause it and see if you can do it. But if you multiply these out, you will end up with x cubed plus 927. Turns out that when you multiply this binomial by this trinomial, a bunch of stuff cancels, you end up with this. Same thing over here. You'll end up with an 8x cubed plus 125. All right. So when you multiply these, you end up there. Now, that's actually not what we're doing today. That was last section was when we learned how to multiply polynomials together. So what we're doing today is your questions are going to start looking like this, and then you got to get it back into the two things that are being multiplied to end up with that. So your question will look like this part right here. And then it's going to say to factor. Once you factor, you're going to end up into this. Okay. Same thing over here. It'll go like that. So in class, we figured out the pattern on our own, but basically you'll end up with two special patterns. First one looks like this. So if you have a perfect cube plus another perfect cubed, when you factor, you'll end up with a plus b, a squared minus ab plus b squared. And there's another one for minus. When you subtract, you end up with a minus b, a squared plus ab plus b squared. So if you'll notice, a cubed plus b cubed, the first binomial is just whatever was being cubed. So the a and the b just end up there. The second trinomial, the front and the back are just the a and b being squared. And then the middle part, you multiply the a and b together. Okay, so it's just a whole bunch of a's and b's. The part here that most people get thrown off on are the signs. So the plus, minus, plus, and minus, plus, plus. Something that I've learned that helps people memorize this is SOAP. So if you look at this, if you're starting with this as your question, the first sign is a plus because S stands for same, so same sign as the beginning. Second sign is opposite sign from the beginning, and last one is always positive. So if you have a minus, same sign is negative, opposite sign would be positive, and the last sign would always be positive. Okay, so these are two formulas for the special pattern for sum and difference. Let's try it out. So first off, we got to figure out what the perfect cubes are. So x cubed is an x being cubed. 8 is a 2 being cubed. So that's your A part and that's your B part right there. So what's going to happen here is you're going to end up, we know we have perfect cubes, so we can end up with a binomial and a trinomial. So go ahead and put your groups in. So remember the first part, all you do is you figure out what your A is and your B. That's just your A and your B. So we found an X and a 2. So this is going to be an X and a 2. Now the front and back parts of the trinomial are going to be the X squared and then the 2 squared. So X squared is an X squared. 2 squared is a 4. Okay, so first just put the X and the 2, then square them on the front and back parts here. And the middle part is just multiply them together. That's your AB part. So 2 times X is 2X. Now we're going to use SOAP. Hopefully you always use SOAP. But in math, we're going to use it right now. So first off is same. Actually, you know what? Let me write this above. So same. Ooh, that was weird. Okay. Same, opposite, always positive. So same sign, so it's going to be a plus. Opposite sign, so minus, always positive, plus. And you are done. All right. So that's how you use factoring sum of cubes. So let's try another one. Let's do the difference of cubes. So this one, 8x cubed. Remember, you got to group the entire thing. Find something that's being cubed. That's going to be a 2x being cubed. To get a 1, that's a 1 cubed. So there's your A and there's your B. Okay. So binomial, trinomial, first part is a and b, so a 2x and a 1. Then a 2x being squared is a 4x squared. A 1 being squared, 1 times 1 is a 1. And then multiply them together, a 2x times a 1 is a 2x again. Now we're going to fill in our signs. Same, opposite, always positive. So same sign as the beginning sign was this right here, so it's going to be that negative. Opposite sign from the beginning would be a positive, always positive means always plus. And that's it. One thing people mess up on here is they think you can keep factoring this trinomial, and they think it's the perfect square trinomial, and it's not. You got a perfect square in the front, perfect square in the back, but this middle term does not check out because it's supposed to be doubled that, and it's not. So this is actually not factorable without using like imaginary numbers or something like that, which we're not going to do. So just leave it like this. It doesn't really factor much more than that for our purposes. Okay, example 3. So let's go do this one. A little more difficult. So first one, something cubed, and it has to be plus something else cubed. So 125 is a 5, and then an x. So 5 cubed is 125, x cubed is x cubed. 27 is a 3. Now, y to what power cubed is going to be a 9. So that's going to be y to the 3rd power. If you remember your power of products here, 3 times 3 would get me that 9. So that's your a and that's your b. So that is a little bit more complex. There's a, there's b. Okay, so your a is a 5x, your b is a 3y cubed. So this first part is a 5x squared, so 5 times 5 is a 25. X times x is x squared. 3y cubed, remember, is a 3y cubed times a 3y cubed. That's how you square it. 3 times 3 is a 9. Y cubed times y cubed is y to the 6th. Or you can think of 3y cubed squared, get the same thing. All right, now what we're going to do is we're going to take this times this. So 5 times 3 is a 15. And then x times y cubed is xy cubed. Fill in your signs, same sign, opposite sign, always positive. Yeah, that looks pretty complex there. All right. Okay, let's go ahead and move on to this one. I'm just going to do the first part here, and then you guys can take it from there. But basically this one, first off, it doesn't look like it's actually a difference of cubes, because x to the 5th, you can't really turn that into a cube power. Neither can you do that for a 16. But when you're factoring, something you should always check for is if there's a common number or a common monomial you can pull out of both of these. So for example, I can, out of 16 and 250, I can take a 2 out of both of those. And both of them have at least an x squared in it. So now I got to think in my head, okay, 2x squared times what is 16x to the 5th? Because this step should not be different from this one. It should just look different. It's actually the same value though. So 2 times 8 is 16. X to the 3rd, because 3 plus 3, when you do x squared times x cubed, you add these and get that 5. All right, so that's going to be minus 250 is 125 when you multiply it by 2. 2 times 125 is 250, and then you took the x squared out, so that's it. Let's move that in some. Okay, so now if you notice, this is now a perfect cube. That's 2x, and then that's cubed, that's a 5, and that's cubed. So you get a 2x squared, binomial, trinomial, 2x and a 5, 4x squared, 25, and then 10x. Same, opposite, always positive. And there you go. All right. Hopefully I'm not going too fast through this. Factor by grouping. So this is the second objective that we're getting into. Second objective is basically we're going to factor this again. So we should end up with 2 sets of parentheses. So I'm going to put that at the very end. Our 2 sets of parentheses, because when you factor, you end up with things being multiplied. Now, you have to have 4 terms for factor by grouping to work. First step is group. When we group stuff in math, we use parentheses. So I'm going to group these first 2 terms, and then I'm going to group these second 2 terms. All right. So I'm going to put the x cubed minus 2x squared as a group. Now, I'm going to consider this like a negative 9. So it's going to be plus, and then I'm going to group the negative 9x plus the 18. Okay, so first off, I just grouped the two. Now, double check to make sure that you can get back to your previous step if you wanted to. So if I wanted to, I could distribute a 1, end up here, distribute a 1 again to this one and end up here. So I didn't actually change anything. They're the same thing still. All right. So now what I'm going to do is I'm going to start thinking about each one of these groups like a separate problem. So what I want to do is I want to look for things that they have in common. So if I think about this one, they both have an x squared in it. So what you can do is you can pull out an x squared, and then you'll have something left over inside of your group. So x squared times x is x cubed. X squared times a negative 2 is a negative 2x squared. Alrighty, and let's see here. Then we're going to do, now the second part, we're going to do the same thing here. Figure out what you can pull out of both of these. Now our goal is we actually want our groups to match. So if I pull out, if I have a negative in the front right here, I actually want to pull the negative out also. So I don't want to just take out a 9 from the 18 and the 9. I want to take a negative 9 out. So you can write plus a negative 9, or you can put minus 9, because that's plus and negative is the same thing. So negative 9 times x is a negative 9x. Negative 9 times a negative 2 is a positive 18. All right, now we don't have our two groups of parentheses, but we have some parentheses going on here. Now, if you think about what we just did, where we figured out what both of these had in common and pulled it out front, if you look really closely at this part right here, this entire red thing is one term, because this is one group times that. So this is all one big term. So is this one. Now, if you notice, one of the factors of those terms is the x minus 2's. This is the same thing as this. So what you can do is pull it out front, just like how we pulled it out front before. So that'll be an x minus a 2. And then the leftovers get put back inside of parentheses, so it's x squared minus 9. Now, it gets a little bit tricky here, just because this might not look very nice and neat. Let me go ahead and put another example of this on the side over here. So let's say that you had a 4x plus 6. This is 2 times a 2x plus a 2 times a 3. And once we see they have something in common, we pull it out, put the 2, and then the 2x plus the 3 goes back inside. That's exactly what we did here. We pulled stuff apart, but then we figured out we had this was in common with this, so we pulled it out here, just like how you would figure out this 2 is in common with this and pull it out here. The leftovers get put back in parentheses, so my leftovers here were the x squared and the 9. Now, in this case, we could actually keep going, because x squared minus 9 is another pattern that we learned how to factor. That's the difference of squares. So that's going to be x minus 2. That's going to be x plus 3, and an x minus 3. And there you go. Okay. And let's go ahead and do this one. We'll do a couple of these. So this one, first off, group them. So that'll be x cubed minus 4x squared plus a 3x minus a 12. Now, what you can do to kind of help yourselves out, if you're having trouble figuring out what they have in common, what you can do is prime factor each part. So, for example, x cubed is x, x, and x. Here's another color. 4x squared can prime factor into a 2, an x, and x. And then you just ask yourselves, what do they have in common? So what they have in common are 2 x's. So you can pull those out front. So that's going to be an x squared. And then the leftovers are an x, and there's a minus sign here, so minus 4. Okay, so you can do it that way, unless you can do it in your head, you can do that too. This is just an option. So if you're having trouble figuring out what a 3x and a 12 have in common, you can prime factor it. It's 3 times x. 12 is a 2 times a 2 times a 3. Looks like they have a 3 in common, so the 3's can come out front. So it's going to be plus 3. And then the leftover parts are the x and the minus the 4. Okay, now what we want to do is we want to look at your groups because there's one more step, because remember, we're supposed to end up with just two parentheses, no plus sign between. So this group is the same as this group. Think of it as like one thing. Pull that out front. That'll be an x minus a 4. And then the leftovers are an x squared plus a 3. This part is no longer factorable. I can't really factor anything into that, so that's it. It's not a pattern or anything. All right, and that's all. That's how you do these. So I do suggest, until you get the hang of it, doing this prime factoring thing until you can get it. Okay, and yeah, you can try that one too if you want. And bring me questions tomorrow if you have them. Okay, bye-bye.